What's up, YouTubes? I'm here doing some development for the 65816, good old Super Nintendo assembly language. That and the SPC 700 for the sound coprocessor. The problem I'm tackling today has to do with having some sample data and having an SPC program, uploading them to the SPC memory from the Super Nintendo 65816 side. And the problem specifically is when you upload, well, it's more like currently my code is uploading it in such a way that I have the sample before my program, and if the sample size changes, the address at which this program arrives at changes, and you need to know what that address is beforehand, because you need to put it right here, and this ends up getting sent over as a start address. After you finish uploading data to the SPC, you need to tell it where to go to execute the program. So you can see how I'm kind of pissed, because when I try to load up other samples, I have to keep doing these calculations. So I started saying to myself, man, it'd be nice if I could modify this program to kind of put the sample somewhere like kilobytes away from my program and upload them to completely separate sections of RAM, and for now at least. And by being able to do that, I don't have to worry about recalculating the address every single time I switch the sample. They can just be in two distinctly different locations. So let's talk about doing that. If you look at the Super Nintendo development manual available at romhacking.net, there's this data transfer procedure, which I'm currently utilizing almost everything in it except for this part right here. Currently I'm just sending everything as one chunk of data, but what I should be doing is sending them as two chunks. That one would be the sample and the other one would be the program, and then I can specify the address of each separate chunk, the start address. And it looks like, so normally I would get to this point, the data transfer. Let's see, oh, it's specify the address. Data transfer start. Send the data and then repeat. So if I want to not do that, let's check this out. So let me tell you what I do. I kind of got a little proprietary format going on here. This is the start address of where I want to start uploading to, and this is from just for my program only. It's this number of bytes of the following data. So what I would do to modify this is I would do this. I'm going to pseudocode this out. We'll call it xbx binary 2. Is I would do the same. Let's see, sample start address. And then at this point, I would like to have a value that would say, which value should I define? Let's skip that for now. Something's probably got to be there, and then there would be an address here. And so the program address has just been duplicated. So if this program address was saved when this was loaded, that this could be eliminated. So it looks like if we could occupy this with a byte that is non-zero, I think that might do the trick. Problem is we can't guarantee. Oh wait. Program address has to be non-zero anyways, so we can just literally delete that, and we can do a check here for 0. So here I'm going to modify this code. The first thing I'm going to do is do a check for the 0 word after the whole thing's been after sample size B bytes have been loaded. So like when this gets loaded, I load it into X register. So I do my initial communications with the SPC, and then I load up X. I think that's right. Hold on. No, that wasn't it. It's this one right here. And then I do a DEX. Where's my complex? Right here. What's this counter all about though? Okay, got it. So that counter, if you're actually with me, I don't expect you to be with me, this is kind of like specifics, but basically this is an implementation of this protocol here, and port 0 initially starts at 0 when you start uploading data, and you need to continuously keep a log of that each time you upload a new piece of data. I think that's a word of, I mean a byte of data. Is it a byte? I can't remember. Yeah, it's a byte. Wait, rep, story tone 40. Yeah, it's a byte. You have to increment also port 0. So that's all that was happening here. I load up my data, and then I'm using some tricks to use the 16-bit width of the accumulator. I have half of that 16 bits, like the upper 8. I'll switch it. This is like this swaps the upper and lower halves of the accumulator, so you can work with the whole 16 bits, 8 bits at a time, by switching the high half into the low half. You can work with it when you're in 8-bit accumulator mode, and that's like a piece of the register I'm using to work with that port, keeping port incrementing, and the other half I'm using to grab my data, and then I write it as a word because conveniently the data gets the port is in port 0 and the data is in port 1. I can write that as a 16-bit value, but you know, I wasn't planning on talking about that. So I think I decrement X, and then I'm still keeping track of my counter here. Let's see. So it looks like I need to check for the port 0 after the write. So, is that right? Yeah. And then I'm going to start sending this new data. So first we get here. We finished. After this passes means we finish sending all of the sample bytes, and then we're gonna do the check for the port incremental thing. Make sure we're in sync. I put the port incremental thing back into the upper half of the accumulator. Yeah, I'm a little nervous. Reading assembly made me nervous. Now at this point, I want to read this code so I know what happens here, but this is the entry point for my new additions. Well, let's read what happened here. I load up X, I see if it's 0. If it is, I go to some termination section. But would it be 0? Yes, it would be 0. By the way, this needs to get removed. Oh, that's the old one. Wait, so this might be exactly what we need here. This code might actually already be present, the code that I'm looking to add. So if it's not equal, let's see what happens here. We load this first value, which should be an address at this point of our next data segment. And then he loads 1 into port 1. Port 1 used to be not 0, so that's cool. Port 2, 3, that should be X. And then what do I do here? XBA. Port 0. What the heck is this all about? I don't know what this little loop is about. XBA, INA. I don't know why I would do such a thing. I don't get this +2 to 127. Let's check out the terminate thing, see if we can make sense out of that +2. This is the same thing here. I guess what happens here is we increment at least twice, because that's the mandatory. And then if that happens to roll the register over to 0, we go back and then increment it one more time to make it non-zero. I guess that's it. Yeah, total not equals 0. I trust that works. So anyway, going back up here, yeah, so this is all set. So everything's taken care of. All I have to do is leave this here just because of good reference. But I'm just thinking at this point. I want to keep the program and the sample a good distance from each other, because sometimes I change the program code and then the program size changes, which affects the sample start address, which will affect later. You know, the SPC code needs to reference where the sample will be in memory. It'd be nice if there was an automated script that could take these, like the address, the knowledge of the addresses and the knowledge of the file sizes, to be able to automatically generate this type of entry that I can just copy and paste. That would be probably uber useful, huh? I'm just not sure if that's exactly what I'm going for right now. If anything, my main concern is you need to have like a sample, like a sample. I forget what it's called. It's like a table. And my table's at address 3000. It shouldn't be a problem. I think what I can do is, I think what I'll do is this. What's the size of my... This thing's only 99. Oh, I'm sorry, I messed that up. 63 bytes. I could just put the thing in decimal the whole time. And this one would be nice to be somewhere like far away. Oh, I messed up, yo. $1080, bro. How much is 1080? See, I don't want to have to be able to do this stuff like manually, you know? It'd be nice if I could just do it and have it taken care of. You know, I really feel like this should be opposite, but I'm not gonna mess with it. I should mess with it though. See, I don't recall what this table format is. I think this must be where the address of the sample is, because that forms the address 200. So what I could do is make it 1000. Have my program be at 200. I would prefer that. Oh, there is a problem with my code, I think. Here's the problem. I loaded X. I loaded X. The problem is this X right here is the address. This X is the size, but it wouldn't work if it was that way. The only way it would work is if it was opposite. I think what I'll do is this. This is what's gonna happen, really. See if this works, dudes. I'm gonna compile the sound processor code right there. Compiling with TASM. I have a version of TASM for OS X. I don't know how the heck I managed to get it on here, but I have it. So you know, if anyone wants it, I should host that. You can also use WLA for that. Hopefully this thing works. Yeah, that's not working. I don't know why I'm opening it again. You know what I did? I didn't up that's gotta be updated right there. Let's try again, huh? Alright, just because I'm not sure what's going on, I'm gonna put this back. But this is really gonna be a, yeah, put that back to 200. And then put this to 1000. Man, nothing. So now it's like, could go into a debugger. Let me see. I really need a symbol file. Is this new? Yeah. So what I could do is, before I do that, I really want to see if I can just read the code and discover what's the problem. Here's a problem. I don't think this is the problem though, but that is a problem right there. Not the problem. I got the problem. I see it. No, I don't see it. I thought I saw it. Well, I'm gonna load it up in the debugger, see what happens. Whoops. This is the A639. Alright, found the problem. I think it's this. That is what I think right there. Well, let's look at the discrete data loop. Load A, XPA. How come I took that out right there? I think I get what's going on. I can't, it's hard to explain. Let me just try this. Let me try that. I really expected that one to work. Anyway, we're back there again. Trying to figure out what's up with that. I'll try to put this in sequence too. Port 0 is written last. Port 1 is written first. No dice. Oh, I see the problem again. No, I don't. I'm not really sure what's going on. Let me try to add a different. Alright, I'm gonna take a break, dudes. I don't want to leave you bored forever, you know what I mean? I'll let you know if I get anywhere with this. Okay, I figured out the problem. Let's take a look at the manual. The problem was when you go to send the next data block, you return to data transfer start, meaning that you send 0 to port 0. You don't keep on doing this incremental port 0 thing. You reset to 0. So in my code here, where is it? I gotta find it. I basically, right here, I doing some hacks to get it to work. I load it with FF, and then when I go back to my data loop, it gets incremented as per the data loop, which will increment it to 0, so it fits nicely into the rest of the code. And now it works. Check it out. Did you hear that? Oh. I noticed that sometimes it doesn't make the sound, but there it is. Wish I could test it on real hardware right now, but I can't. Let's try it in SNES. It's because I'm hitting breakpoints. Good. It works. Great. So now at this point, I have a sample I can reference, which is blog.brr. I have an SPC program I can reference, addresses I load them into. So the next step will be using blog's APU API with the C and the STL program. See if I can load this into the APU core and play it.